Okay, so in this problem says a suspender rod of a suspension bridge is 25 meters long. 25 meters is roughly the width of this room. So one of those suspension cables is this long. Okay. Have you guys ever, who has seen that bridge in Jacksonville, the 9A bridge? Huh? You like that bridge? Have you driven over it?
It's like your favorite bridge, right?
I do have a favorite bridge, okay? I love bridges. Okay. Who has... I won't even talk. Which one?
The blue or greenish one.
Oh, yeah. What's that?
So, and I've got like an old car, so there's rough going on.
I'd like to ride my bike over that bridge one day.
Good luck with that.
It can be done.
It can be. It's just tough.
All right, let's get back to this problem. I got a suspender rod of a suspension bridge is 25 meters long. If the rod is made of steel, what must its diameter be so that it does not stretch more than 1 centimeter? So this is something you would have to do as a civil engineer. Okay, so here's this rod, and you don't want it to stretch more than 1 centimeter. And you guys, I mean, this is intuitively clear. The thicker the wire, the less it'll stretch. And now the question is, well, I mean, the thicker the rod, the more money you're spending.
Right.
Okay, so you have to do all these calculations. I mean, you're balancing cost versus strength. Okay, making things bulletproof costs more and more money. Okay. So, yep. Mm-hmm.
So for this equation, we just assume that it's a one-dimensional rod.
Right.
In the first problem that we discovered, or that one problem we discovered, that it was supporting 700 newtons of weight, but only had like 750 newtons of tension in that one, the one with the building. With the angle of the boom.
Yeah. Well, I mean, in all these problems,
Yeah, no.
well, now we're concerned about the stretch in this wire. Okay, that's what we're concerned about. Did I start the recording? Is this recording? How do I know? Yeah, it's recording. All right, so there's L, and you don't want it stretching. The stretch is 1 centimeter. Okay, so again, Young's modulus is stress over strain. And by the way, so more than 1 centimeter when a 25,000 kg truck passes by. Okay, I didn't draw it. Assume that the rod supports all of the weight of the truck. So what they're saying is okay, so again, here's one of these rods. A truck passes by, and they're telling you assume that this rod is supporting all the weight of this truck. Okay. All right, so what is it that we want? Area. Okay, what must be its diameter? So Okay. So force is mg. All right, so now let's and y is, I'm assuming it's the same as the last problem. And you don't want it stretching more than 1 centimeter. Okay. So you guys see from this equation, greater the stretch, smaller the area of cross section. Thinner the wire, greater the stretch. Okay. All right. So r square is, let's take care of powers of 10. This is 10 minus 7, and then we'll kill 3. That's 10 to the 4. We'll bring 10 to the 4 up. Okay, so 25 into 9.8 into 25 into 10 minus 4 meters, pi into 210. Okay, that's it. Okay. 3 centimeters. 3 centimeters is about that much. So it's about this thick. The wire is about this big. Okay. So those cables on the bridge. Okay.